As you probably already heard and saw, today we're going to talk about Kubernetes. But what is actually Kubernetes? Kubernetes is an open source container orchestration tool. It was developed in Google, open source in 2014, and for the past 7 years became the de facto standard for managing and deploying container applications. However, today we are not going to talk about deployments or container orchestration. We're going to talk about how we can take Kubernetes to the next level, and that is using it as our application development platform or framework, if you'd like to call it that way. In order to showcase this approach, we're going to build something. And what we're going to build is a conference management system. Think, for example, of ISTA conference. On ISTA's website, you can go and you can see all the sessions with more info about each conference talk, more info about each speaker, and so on. So we're going to build something similar, only ours is going to be a bit simpler. Our domain is going to consist of two main models, a conference talk and a speaker, where each conference talk has a title, a summary, and a speaker, and each speaker has a name and a bio. In order to build this, we need, in technical terms, 2 or 3 main building blocks. And that is, first, an API backend for creating, reading, updating, and deleting resources, or the so-called CRUD API. Then we need a database to store these resources in. And last but not least, we need a UI to visualize everything. Now, Kubernetes cannot really help us much with the UI, so we're not going to talk about this today in today's presentation. We're going to focus more on the other 2 parts of our system, the API backend and the database. And now some of you might say that this is a pretty standard problem to solve, and there is more or less a standard way to solve it. And you will be right. The standard way would be to pick your favorite programming language, bundle it with a web framework, choose some database engine, maybe a UI framework, and use this as a scaffold for your application. But this approach is not without its pros and cons. Let's see what they are. First of all, basing your entire application on a framework like Spring or Django has both positive and negative sides. On the positive sides, these frameworks are quite big. They give you a lot of stuff out of the box. They have been around for a long time and they are used by many people in production. They have long-term commercial support, basically everything you might need or want from a framework. On the negative sides, however, the fact that these frameworks contain a lot of stuff out of the box means that they're quite big. And probably you won't be using everything that these frameworks have to give you. So you need to either spend the time to strip them out of all these unnecessary parts, or you need to ship your application along with them, thus making it bigger and slower. Also, such tools give you the capabilities to write an API, but they don't actually guide you through the day-to-day operations of managing an API. For example, if our API is going to be public, if we're going to give it to our customers to interact with it, we're going to need documentation. And indeed, documenting an API nowadays is not a hard thing to do. You have standards like OpenAPI. You have a lot of tutorials online on how to document an API. So this is not the challenge here. The challenge comes when you have to make sure that this documentation is always up to date with the API. What I have often seen in practice is developers updating the API, but forgetting to update the documentation. And what happens in this case is that your customers, they start seeing things in the UI which they don't know anything about because they are not in the documentation. And they get confused. Or your API having capabilities which your customers are not using, again, because they're not documented and your customers don't know about them. So you need to figure out a way to tackle this problem by yourself. Another thing is API versioning. Your product will evolve and the API will evolve as well. And inevitably, sooner or later, you need to make a backwards incompatible change to your API. Backwards incompatible change means deleting a field or renaming a field or changing the type of a field. Basically something which will break existing integrations. And the question here is, what do you do in this scenario? Do you release a second version of your API with the new changes and maintain both the first and the second version simultaneously? Do you deprecate the first version? Do you just delete the first version and tell your customers to update immediately? These are all questions which you have to answer by yourself, and on which these tools are not opinionated on. So you're on your own here. Enough with the problems. Let's see what is the alternative that we're suggesting. As I began, we're going to use Kubernetes as our application development framework. What this means is that we're going to build an API backend entirely as an extension of Kubernetes API. We are not going to build an application which we will deploy into Kubernetes, but we're going to extend Kubernetes itself in a way that Kubernetes is our API backend. We can do this because Kubernetes is by design flexible and extensible, And it provides you with a lot of constructs which allow you to extend Kubernetes in a way that it fits your use case. I'm talking about things like custom resource definitions, admission controllers, and operators. And indeed, people have been using these constructs to extend Kubernetes for a while now, and this is what we're going to do in today's talk. Let's start with our domain objects. We're going to represent them as custom resource definitions, or CRDs. Now, if you don't know what a custom resource definition is, it is exactly what it sounds like, your own custom Kubernetes resource. The same way that you have resources like pods, deployments, services which come from Kubernetes, the same way you can define your own custom resource, which you have full control over it. You define what properties it has, what types are these properties, what happens when you create one, what happens when you delete one. And we're going to leverage these capabilities for our domain objects, the conference talks and the speakers. Now, in more technical terms, what happens when you create a new CRD is Kubernetes registers new API endpoints to the Kubernetes API so that you can use them to interact with your resources. And Kubernetes also provides implementation for these endpoints. This implementation includes serialization and deserialization of the request and the response, validation based on the open API spec of the resource, and the logic which reads and writes from the database. Let's see how this looks in practice. This is the custom resource definition for our conference talk object. This is a Kubernetes spec file. We see its kind is custom resource definition. And down below, we have all the fields for our type. The name of our kind is conference talk. The API group is istacon.org because we are at ISTA. And we see we have one supported version for this API. This is version v1. And we see it has an open API spec, which consists of the three fields we talked about in the beginning: title, summary, and speaker ID. Now, this, as you see it, solves two of the problems we talked about in the beginning, the documentation and the versioning. Why does it solve the documentation problem? Well, because CRDs are usually something which is public. So you can just give this CRD to your customers and you can say, this is my API, this is how you interact with my API. And because, as I said, custom resource definitions are something quite standard in Kubernetes, people who are already familiar with Kubernetes and with custom resource definition can easily get familiar with your custom resource definitions as well. Now, if your customers are not familiar with custom resource definitions and you don't want to bother them with Kubernetes specific things, this here is just an open API schema. So you can use this as your source of truth and generate another documentation, which is Kubernetes agnostic, based on the fields in your CRD. But the bottom line is that this represents your API, and this is how your API looks like. And because Kubernetes will provide the implementation of this API for you, there's no way that your documentation will diverge from your implementation, because one begins with the other. If you listen to the previous talk about API first design, this is basically one way to do API first. About the versioning, if we want to have second version of this API, the only thing we need to do is we need to add another entry in this version spec here. For example, v2, which will have different API schema, which will not be compatible with version 1. And for things like deprecations or removals, the only thing we need to do is we need to tweak these fields, these two fields here. And this way we can deprecate or remove an API. And again, this is all pretty standard in the Kubernetes world. This is our second CRD for our speakers. I don't have much to say about it because it's more or less the same. We see now the kind name is different, is a speaker. The API group is the same, istacon.org. And again, we have one version which has an open API spec, and we see the two fields for the speaker in this open API spec. This is the API scaffold. This is how the API looks like. But if you want to create actual instances of these objects, we can do it like this. This is again a Kubernetes spec file which represents our custom resource. We see now the kind is conference talk, and the API version is istacon.org v1, basically what we saw in the previous slide. Then we have some metadata, and then we have the spec with the three fields for these resources. And we have the same thing for the speaker. Kind speaker, API version istacon.org v1, some metadata, and the spec with the speaker fields. Applying these two YAML files to a kube API, which already has the CRDs from the previous slide registered, will automatically create these two objects in the Kubernetes database for you, and you can later get them, read them, interact with them in whatever way you like. I have recorded a short demo to see how this looks like in practice. So I have a Kubernetes cluster here, and I'm interacting with it with kubectl. And what I'm doing here is I'm applying the YAML from the first flight. I'm creating the custom resource definition for the conference talk. And I see that I have it now created. The second thing that I will do is I will create an actual instance of this custom resource definition. So I'm creating a conference talk custom resource. And now if I kubectl get my conference talks, I will see that I have one object of this kind, the Kubernetes extensibility, which I created 7 seconds ago. If I want to see more details about this object, I can just specify its name when I'm kubectl getting it. And this will show me the full spec of this resource. Here it is, and we see we have some metadata which is added by Kubernetes, and in the bottom we see the spec which we have specified. So this is how our API looks like. And this is kubectl, but we can interact with Kubernetes in other ways. And one way is to just do an HTTP call to the Kubernetes API. So I can just make a curl request, and this is how the HTTP API looks like. ISTA.conf.org, which is our API group. Then we have v1, which is the version, and then the name of the resource, which is conference talk. And if I execute this GET request, I will see basically the same thing we saw previously, only in a slightly different format. It's now in JSON format, and we see here in the items we have an array of conference talks, and we see we have one conference talk, which is what we saw previously, the same one, and it's back here. Okay, so what have we achieved? What have we achieved so far? We have a CRUD API backend, which is entirely as an extension of Kubernetes API. And we have the ability to create, read, update, and delete resources via the Kubernetes API. And these resources are automatically stored at the Kubernetes database. And we achieved all of this without writing a single line of code. It looks something like this. We have a user which creates conference talks. Then we have the kube API server, which writes these to etcd. And in the other way around, a user which reads conference talks, we have the kube API server which reads them from his database and returns them to the user. Okay, but what if we have more business logic? What if we have some dependencies between our objects? For example, when we are creating a conference talk, we need to make sure that the speaker referenced in this conference talk actually exists. Or we want to run some actions when a conference talk is created, like send an email or publish a social media post. To achieve this, we cannot do it with CRDs alone. We will need to use more of these extensibility constructs we talked about. So let's see what they are. Starting with validation, we can use admission controllers for that. And this is a controller which allows or denies the creation of a resource. What it does is it reviews the request before that resource is created. Based on some logic, allows or denies the creation of the resource, and the kube API server respects this decision. Kubernetes gives you many admission controllers out of the box, mostly used for security and authorization, but it also gives us the capabilities to write our own admission controllers. And in our case, this is the perfect place for implementing our validation. In more technical terms, an admission controller is just a webhook which is called by Kubernetes. This webhook contains some logic. It receives a standard request, and it should return a standard response, which response contains whether the request should be allowed or not. Then the kube API server will parse that response, and it will do whatever the response tells it to. The picture now looks something like this. When a user creates a conference talk, it first goes to the admission controller, which allows or denies the creation. If it denies it, the given conference talk will not be created, and the user will get an error. If it allows it, the same thing will happen as before. The kube API server will write this resource to the database, and you can later read it, update it, delete it, whatever we want to do with it. Now we know how to do the validation. But what about some post-create actions? For this, we can use operators. An operator in Kubernetes is something like a controller for custom resources. What an operator do is they listen for create, update, or delete action of a given custom resource. And once that happens, they run some code. In our case, this would be the perfect place for implementing the business logic. In more technical terms, an operator is a web service which interacts with the Kubernetes API and listens for resource changes. And when that happens, it runs some code. The good thing about operators is that we can generate most of the logic based on the CRDs. So all the Kubernetes specific logic about interaction with the kube API, listeners, reconciliation loops, all of this, we can get it generated by us. And the only thing we need to implement is our business logic, which is basically one method which says when a resource is created or updated, execute this logic. And now we know how to achieve this as well. The picture now looks something like this. We have a user which creates conference talks. This is verified by an admission controller. If it's allowed, it goes to the kube API, which writes it to the database. And simultaneously, the operator will hear that the conference talk has been created, and it will run all the logic which we have implemented it to run. Now, I would like to mention some details. First of all, this solution uses etcd as a database. etcd is a NoSQL database which comes by default with most Kubernetes installations. Kubernetes uses it to store the desired state of the cluster. And in our case, we are reusing that to store our resources as well. In our scenario, this is okay because our data is really tiny. It's like 2 or 3 fields. But for more complex use cases, for if your data is going to be, if you're going to be using big data or you have really complex objects, you'll be better off using a regular database like Postgres or MySQL, because etcd isn't really built for high scale and for big data. And in this scenario, you will be better off using another type of database. Even if you do need to use that, you can easily provision a database in your cluster with a database operator. You already know what an operator is, and most of the database vendors, they provide you with operators which you can install in your cluster, and then using some CRDs, provision databases for you in your Kubernetes cluster in a Kubernetes native way. Another thing which I kind of mentioned, but I wanted to reiterate here because I think it's important, is that kubectl and YAML files is not the only way to interact with your Kubernetes cluster. This is more or less the standard way and what we are used to. But how this works under the hood is that Kubernetes actually exposes an HTTP REST API, and kubectl is just a wrapper on top of that. So if you need to do some integration, or you just don't want to use kubectl and YAML files, you can easily just use the REST API and interact with that. And of course, you already saw in the recording how with a simple curl request, we got our conference talks from the API server. I would like to show you more, but unfortunately, I don't have the time today. So if you want to see the full picture with the code, the implementation of operators and admission controllers, it's all in my GitHub profile. It's asankov-cb/kubernetes-extensibility. There you will find instructions on how to run everything in your Kubernetes cluster, how to play around with it, how to modify it if you want to, and you can check it out. If you have any questions or feedback, you can contact me. I'll be happy to answer. My socials are on the next slide, or you can just open an issue here on GitHub. Now, this is the end of the presentation, and if there's something to take away from this is that there are many ways to build a web application nowadays, and new technologies like Kubernetes motivates people to start building applications in new ways. Of course, this approach is not without its negative sides. So it's all a matter of trade-offs, and when you are evaluating how to write your next application, you need to make the right choices and see what works best for you and which trade-offs you're willing to make. And currently, we see this approach really popular for products which need to provision something in Kubernetes, like databases or some lifecycle management of some components. Yeah. Thank you very much for the attention. I'll be happy to take any questions now or later on any of the links here. Thank you.
Thank you, Anton. Those were some very interesting insights that you shared. So far, we don't have any questions from the audience, but I have something in mind that I wanted to ask you. Can you think of any practical examples of using this approach? Any projects that are implementing it?
Yes. Yeah, so as I said, it's really popular in lifecycle management. And one of the examples I gave in the presentation was with a database. So most of the database vendors use this approach to give you an easy way to provision a database in your cluster. So for example, if you want to have PostgreSQL running in your cluster, you have a PostgreSQL operator and you have a PostgreSQL CRD. And when you create the CRD, the operator, based on some configuration, the CRD gives you provisions a database for you in your cluster. And another thing is lifecycle management. We are using it on the project I'm working on. We are doing security for Kubernetes, and we have some components which are running inside your cluster. So we have an operator which provisions these components when you apply our CRD. So this operator is taking care of all the specifics of our components. So it does a lot of work in the background for you, so that you don't have to do it. And I think this is really popular for these use cases because it fits really well with the declarative nature of Kubernetes APIs, because it focuses on what you want and not on how you want it. And this is how most of the Kubernetes APIs work, and it fits really nice with them.